The end of our sample final. Last three questions. First one asks me to solve an equation. It's a little tougher than the last one. First off, I don't just have the root on one side, everything else on the other. In order to do that, I first have to move this n by saying plus n to each side. Then on the left-hand side, I have 15 minus 3n. On the right-hand side, I have n plus 1. Now when I square the left to get rid of this root sign, squaring the right really means foiling out n plus 1. So this does not equal n squared plus 1. You need a middle term whenever you multiply a binomial by a binomial. The left-hand side does just become 15 minus 3n, but the right-hand side becomes n plus 1 times n plus 1, which really gives me n squared plus 2n plus 1. To go over how that's happening, when I do n plus 1 times n plus 1, n times n gives me n squared, n times 1 gives me one of these n's, 1 times n gives me other n, and then 1 times 1 gives me 1. It's very important that you get this middle term, this 2n, or else you're not actually doing out the multiplication that it's asking you to. I can now move everything to the same side by doing plus 3n minus 15, plus 3n minus 15. Over here, everything goes away and leaves me with 0. On the right-hand side, I get n squared plus 5n. 1 minus 15 gives me negative 14. This can be factored. N and n bring down the positive. That says different than, different from positive, is negative. Two things that multiply to 14 and subtract to 5. Well, the ways to multiply to 14 are 1 14 and 2 7. 14 minus 1 gives me 13. That doesn't work. 7 minus 2 does give me 5. So I'm going to put the larger one here, the smaller one here. Normally I could stop there by factoring, but here it tells me to solve the equation. So I really need to say what makes this 0. Well, to make n plus 7 0, I need n equals negative 7. To make n minus 2 0, I need n equals 2. So I'd write these answers as a comma-separated list, negative 7, comma 2. Here we're asked to use the quadratic formula to find all real solutions. In this case, we already have everything on the left side in the right order equal to 0. So I can right away start pulling out a, b, and c. A is in front of the x squared, in this kind of case, an understood 1. B is in front of the x, in this case a negative 7. And c is by itself with no power of x, in this case 10. I then use my quadratic formula, which says the opposite sign of b. Since b is currently negative, it's going to make it a positive 7, plus or minus the square root of b squared, so negative 7 squared, minus 4 times a, which is 1, times c, which is 10. All over 2 times a, which is 1. Cleaning this up a little, this becomes 7 plus or minus. Negative 7 squared is 49. 4 times 1 is 4, times 10 is 40. So 49 minus 40, all over 2. That becomes 7 plus or minus the root of 9 over 2. At this stage, if what's under the square root is not a perfect square, you can stop here, enter it as two different fractions. One with the plus symbol, one with the minus. In this case, we do know the root of 9, it is a perfect square. So I really have to figure out what the two answers would be using that perfect square. It becomes 7 plus the square root of 9, which is 3 over 2, and 7 minus 3 over 2. Remember, you do the top part before you do the division. 7 plus 3 is 10, divided by 2 would give me 5. 7 minus 3 is 4, divided by 2 would give me 2. So the correct final answer should be 5 and 2. For number 30, I don't have this in the proper form yet to be able to pull out a, b, and c. It's not set equal to 0, so the first thing I need to do is subtract 6 from each side. That gives me 5x squared minus x minus 6 equals 0. Now I can pull out that a equals positive 5, b equals negative 1, and c equals negative 6. I put these into the formula. X equals 1 plus or minus the square root of negative 1 squared minus 4 times 5 times negative 6 all over 2 times 5. As I clean this up, it becomes x equals 1 plus or minus the square root of 1 minus 4 times 5 is negative 20 times a negative 6 is positive 120 all over 10. This becomes 1 plus or minus the root of 121 over 10. Again, that's a perfect square. So I didn't actually do this intentionally to make that a perfect square. I thought I was giving random numbers. If you get one here that's not a perfect square, the way I would enter this into Cengage is as x equals the fraction 1 plus root 121 over 10, 1 minus root 121 over 10. But again, since this is a perfect square, I have to do what I did above. This is really 1 plus or minus, outside of the root 121 becomes 11, all over 10. So that means x equals first the positive version, 1 plus 11 is 12 over 10. Then the negative version, 1 minus 11 is negative 10 over 10. The way I'd actually write these are x equals 1.2 or negative 1.